objective physics questions from DC Pandey. It's a wonderful book, and through that, we're going to be doing some questions. Today's topic is going to be on charges and electrostatics. We're going to be doing the first part basically on charges. Before we go to the questions, we'll just revise some important points about charges, which you all know many things, but we'll just revise some important points that you might want to pick up. One basically is what you're going to do is you're going to remember about this important point that like charges will repel each other, right? You know that one part. And the other thing we need to also remember is the property which differentiate two kinds of charge is polarity, right? And the third part you need to know is it is a scalar quantity, right? And the fourth point is they can be transferred from one body to the other. Charge is invariant. It does not depend on the velocity of the charged particle, which is another important point you want to remember, right? The next important point you want to know is that charge, we talked about this important point that when a charge is invariant means it does not depend upon the velocity of the charged particle. But if the charged particle is moving, then it will have both the electrical as well as magnetic field around it. A charged particle at rest will produce an electrical field. A charged particle in motion will produce both magnetic and electrical field. But basically, when there is a charged particle which is accelerated, it will produce electromagnetic waves. So very nice points that we revised. And the next important point you want to note is how much is Coulomb in related to CGS. There is a unit of CGS which is called as 1 stat Coulomb. The other thing that you might also want to note is that apart from stat Coulomb, there is another important unit called the ESU, or 1 Coulomb is actually 3 into 10 to the power 9 ESU, or 1 by 10 EMU of charge. These are the other kinds of units. ESU, EMU are all CGS units. What is the dimensional formula for a charge? You know that basically Q is equal to AT, or A is equal to Q by T, which means the charge per unit time is current, and so therefore Q can be written as AT, and so that is your unit of charge. So these are some important points which you have to remember. We saw this question wherein they asked about the amount of number of electrons that is there in a net unit charge. That means if there is an electron, where there is a charge of 1 Coulomb, then how many electrons are there? We saw that N is equal to Q by E, and from that you know that you need to remember this, that the number of electrons per unit Coulomb charge is 6.25 into 10 to the power 18. If it is basically electrons, then the number of charges for a negative charge is so many gain of electrons. Loss of so many electrons is equal to 1 unit positive charge. So 6.25 into 10 to the power 18 electrons constitute 1 Coulomb of charge, right? Let's look at this simple question about a sphere of lead of mass 10 gram has net charge of 2.5 into 10 to the power minus 19 Coulomb. Okay, now you know that it is a sphere of lead which has got a mass of so much. He's asking you to find the number of excess electrons on the sphere. Okay, and how many excess electrons per lead atom? The atomic number of lead is given as 82, and its atomic mass is given as 207 gram per mole. So 1 mole of the substance will have 207 grams. Right. Now let us just analyze this question. A sphere of lead of mass 10 gram has a net charge of minus 2.5 to 10 to the power minus 9 coulomb. You know that if the net charge is so much, for net charge of 1 coulomb, you have 6.25 into 10 to the power 18 electrons, right? So if the net charge has to be minus 2.5 into 10 to the power minus 9 coulomb, therefore you know that 6.25 into 10 to the power 18 into minus 2.5 into 10 to the power 9 will be the amount of electrons that will be present, and so that will give you 1.56 into 10 to the power 10 electrons is the total amount of net electrons that the sphere of lead will have in excess, right? So from that you come to know the number of excess electrons per unit this sphere of lead. But this sphere of lead, which has so much excess electrons, is for 10 grams, right? You want to know per mole. Per mole there are 207 grams. So therefore 10 gram of lead, right, will have, you know, so many electrons. Per mole, how many will be present? Per mole is nothing but 10 divided by 207, right, into basically the number of atoms. So you need to know the number of atoms that are present in 10 grams of lead. You know the Avogadro number, that 1 mole will have 6.02 into 10 to the power 23 atoms. So therefore the number of atoms that are present in 10 gram will be 10 by 207 into 6.02 into 10 to the power 23, which will give you 2.91 into 10 to the power 22 atoms. So you know the number of atoms now that are present in 10 grams, right? And if 1.56 into 10 to the power 10 electrons are present in 2.91 into 10 to the power 22 atoms, the number of excess electrons per lead atom will be nothing but 1.56 into 10 to the power 10 divided by 2.91 10 to the power 22, which will give you 5.36 into 10 to the power minus 13 electrons per lead atom. So this way these kind of questions can be given. You need to therefore remember that the number of atoms that are present per unit mole is nothing but the gram weight divided by mole into this Avogadro number 1, and the total number of excessive electrons is nothing but 6.25 to 10 to the power 18 basically, which is the number of electrons for per coulomb into the charge will give you the total number of electrons. So 2 important points which you learned from this. Let's see this some important questions. One metallic sphere A is given positive charge, whereas another metallic identical sphere B is given exactly the same mass of A is given an equal amount of a negative charge. Then what is happening to the mass? So here there's a question which is basically asking you in which of the conditions the mass is either increasing or decreasing. We know from the basic concept that when electrons are added, the mass will increase, electrons are removed, the mass will decrease. So which of them is going to have a greater mass? Basically the one having the negative charge, right? So which one is, A is positive, B is negative, same mass, but what is happening? The one having B is going to have a slightly increase in the mass. So the answer for this is going to be D, that is the mass of B increases, right? We'll go to the next question. When 10 to the power 14 electrons are removed from a neutral metal sphere, a neutral metal sphere has got 10 to the power 14 electrons which are removed, then the charge on the sphere becomes, now simple, straight away here, you know, you can remove 2 choices, because here what is happening? Removed. When electrons are removed, what is going to happen? You're going to be left out with a positive charge. So the answer cannot be negative. The answer has to be a positive charge. It's either 16 microcoulomb or 32 microcoulomb. And you have removed 10 to the power 14 electrons. So to get 1 unit, 1 coulomb of charge, you need to remove 6.25 into 10 to the power 18 electrons. So you've removed 10 to the power 14 electrons. So the charge that is going to be left out is 6.25 into 10 to the power 14 electrons. 6.25 to the power 18 into 10 to the power 14. So that is how much? 6.25 into 10 to the power minus 4. Or you can basically write that as what? Into 10 to the power minus 6. If I were to write it out, then it will be written as roughly, 16 microcoulomb. So the answer will become 16 microcoulomb. Right? Good. Right, so you need to multiply 10 to the power 14 into not 6.25, 1.6 into 10 to the power minus 19 coulomb. Why we need to multiply by 1.6? It's basically because you're removing so many electrons. So the charge on an electron is 1.6 into 10 to the power minus 18. So the minus 19. So multiply that by 10 to the power 14. You will get 1.6 x into 10 to the power minus 5, or 16 into 10 to the power minus 6, which is 16 microcoulomb. Right? So the answer you got here is 16 microcoulomb. A conductor has 14.4 into 10 to the power minus 19 coulomb of positive charge. That is the net amount of charge. The conductor has how many electrons in excess or in short? Simple, because it is a positive charge. So therefore the electrons basically that it will have will be deficient. It cannot be excess. And how much? Simple, you need to multiply one charge of an electron, which is 1.6 into 10 to the power minus 19, into number of electrons, should give you 14.4 into 10 to the power minus 19. And so therefore, what multiplied by 1.6 can give you 14.4? Simple, 16 nines are 144. Remember 16 table, 16 nines are 144, and so therefore 9 electrons in short is your answer. Got it? So 9 electrons in short is your answer. Okay, we'll go to the next question. The charge on an alpha particle is 4.8 into 10 to the power minus 19, 1.6 into 10 to the power minus 19, 3.2 into 10 to the power minus 19, or 6.4 into 10 to the power minus 19. So what is the charge on an alpha particle? You know that what is an alpha particle? It is helium atom. So therefore it has to be He plus 2 and atomic mass of O. So it has a charge of plus 2. So what is the charge on an alpha particle? Plus 2. Right? So you need to just have a charge of 2 coulomb. Now, so therefore, what is going to be the charge plus on an alpha particle is going to be due to what? It's going to have a number of, your atomic number is going to be 2, atomic mass is therefore plus 4, right? So the charge of an electron or a proton, both of them you know, is 1.6 into 10 to the power minus 19. Alpha particle has a charge of plus 2 electrons or 2 protons. So if 2 protons are there, that has a charge of 3.2 into 10 to the power minus 19 coulomb. So it has to be a positive, and it will be 3.2 into 10 to the power 19. So the answer is 3.2 into 10 to the power minus 19. Right. A body has minus 80 microcoulomb of charge. Number of additional electrons in it will be, right? So you know this direct thing that the number for 1 coulomb of charge, right? You need 6.25 into 10 to the power 25 electrons. So therefore 6.25 into 10 to the power 23, sorry, 6.25 into 10 to the power 18 electrons into minus 80 microcoulomb. So do that, you're going to get the answer as 5 into 10 to the power 14, right? So that's how you're going to identify the number of electrons that is going to be there in a minus 80 microcoulomb. 6.25 into 10 to the power 18, and that multiplied by the charge is going to give you 5 into 10 to the power 14. Okay. Which of the following is correct regarding electric charge? If a body is having a positive charge, then there is a shortage of electrons. Electrons are removed, and so therefore it is a positive charge, which is right. If the body has a negative charge, there is an excess of electrons. Yes, that is also right. You know that there is a negative charge means there is an excess of electrons. The minimum possible charge is either a plus or minus 1.6 into 10 to the power minus 19, because minimal charge can be 1 E. You cannot have 1/3, 2/3 E, because that basically means it is not a complete integral multiple. Charge has to be a integral multiple. What are 1/3 E and 2/3 E? Known as quark. What are they known as? Quark. Okay, and the net quark has to be equal to NE, which has to be either 1E, 2E, like that. So the minimum is 1E, which is 1 into 1.6 10 to the power 19. And you know the charge is quantized. Yes, it is equal to 1 plus or minus NE, which is 1 to 4. So in this case, all of these are correct. Simple question. When a glass rod is rubbed with silk, what happens? We said it becomes positively charged. The glass becomes positively charged. So if it has to be positively charged, it needs to give electrons to the silk. So it has to give electrons to the silk. A comb runs through one's dry hair, attracts small bits of paper, and this is due to both, one, there is a frictional electricity, secondly, there is a induction, and that induction is creating a polarization. The atoms in the paper get polarized by the charged comb. It is not because there is a charge induced in paper. There is a charge induced in paper, but there is a polarization, and so therefore not due to magnetism or not because it is a good conductor. You know that comb is a bad conductor, paper is a bad conductor, but atoms in the paper get polarized. When a positively charged body is earthed, we know that what is earthing? Earthing basically means it is a removal of the electrons so that the electrons can flow down to the earth. The shock is avoided. When a positively charged body is earthed, what happens then? This means this means that the body is uncharged, charged positively, charged negatively, and insulator. It's telling a positively charged body is earthed. Electrons from the earth flow into the body. So electrons from the earth is flowing into the body. So therefore what then happens to the body? The body obviously has to become uncharged, because what is the purpose of earthing? The purpose of earthing is to either remove electrons or move the electrons from the earth to the body, so that the net charge on it becomes neutralized. So the earthing basically means is basically a mechanism of neutralization. So the body has to become uncharged. We look at this last question before we get into the next part of the chapter, that is Coulomb's law. Consider a neutral conducting sphere. So it is neutral. Now you know that a neutral sphere, a neutral charged body can also get attracted because of induction. A positive charge is placed outside the sphere. Right. The net charge on the sphere is what is happening to the net charge on the sphere. Okay. The net charge on the sphere is negative and distributed uniformly over the surface of the sphere. Negative and appears only at the point on the sphere closest to the point charge. Okay, a positive point charge is kept. Negative and distributed non-uniformly over the entire surface of the sphere. Okay, and the last part basically is 0. You know that it is a neutrally conducting sphere. It will undergo an induction only if there is a mass charge or a bigger charge which is actually closer to it. You cannot get induction on a point charge. If a positive point charge is kept over it, it will not induce any major induction. So therefore, the net charge on the neutral sphere always is 0. Remember this, even if there is a positive charge which is not a point charge, the net charge on the conducting sphere will continue to be neutral. There will only be polarization of the charges. Sometimes unless you earth the body, so then it will be left out with only negative charges. So till such a time the body continues to be neutral. There can be polarization if it is a bigger positive charge which is brought in, not a point charge. If it is a point charge, it continues to be 0. So very important point, that induction will not take place under a point charge, right? So good, important, simple points, some basic calculations. Remember the number of atoms that are there basically in a mole, which is basically your Avogadro number, and also remember the number of electrons that is there basically in 1 coulomb of a charge, be it positive or negative. It is 6.25 into 10 to the power 18 electrons. Good. With this, we'll complete this portion of the chapter. Log in please and continue your great learning. We are going to go into the next part, which is Coulomb's law. So these points is going to make sure that you're thorough in every simple points about physics, that even the most complicated questions will start becoming easy for you. Right, children? Take care. Bye. Shubha Khair.